I am Gary Stuebing. I am the IoT Standards Manager for the Enterprise Networking Business Unit of Cisco Systems. Um, I ended up at Cisco as a result of coming from a company called Duke Energy. It's a small utility in about 4 states of the United States. And the reason, actually, a lot of people don't know this, but one of the reasons that I went to Cisco was Duke was looking for a solution. And um, at the time, this was, I can remember now, it was 7 years ago, actually, that I said, I think Cisco's the closest to having something that's going to be usable. And so I went to Cisco to try to help work through getting mesh networks up and running. Um, when Cisco looks at smart grid and we look at YSUN and FAN 1.0, we saw that there were a number of use cases, and all the green boxes are the ones that we think are just spot on for what we are trying to do with YSUN. If you look at the access size, it's metering, but if you look at distribution, there's a number of things that can be done in the distribution area relative to capacitor banks and voltage regulations and load shedding, especially when you start looking at things like distributed energy resources, solar, wind, battery. So we looked at those things and we said, we think that YSUN is probably going to be the best place to develop a solution for serving all of those needs. And what we wanted was, we didn't want to build multi-networks. We wanted to build a network that was unified, and it had an architecture that could converge all the separate networks that were out there currently in utilities into one network. Because traditionally, utilities had many networks. They had a network for their distribution system, they had a network for their metering, or they had people that went out and read the meters instead of having a network for it. And they had things for their workforce enablement and their volt bar control. But we felt that one solution would be best. If you could get one network, there would be significant savings to the utility. So from a Cisco perspective, the business drivers and benefits. Well, the first thing is you reduce the operations expense. If you could have multiple services running on the same communication infrastructure, everybody saves money. You're not running separate networks. You're not paying cellular carriers to put modems in different equipment. And it's a different situation than it is in some countries in the United States, where the utilities are looking for something that is in their capital as opposed to something that is in their operation expenses. So most utilities in the United States would prefer to build their own communications network rather than use a cellular network or something like that, simply because they can put it into their capital base and they can make revenue on that as a result. But one of the things that Cisco was, or what Duke was really looking at, was trying to build something that had some edge intelligence and would allow them to actually make decisions at the edge of the network when they got into things like outage management and distributed energy resources. The other thing you want to do is reduce capital expense. I talked a little bit about that. And the other thing is we wanted to migrate from all the proprietary solutions. So if you look at YSUN, and I'm going to talk about that in 1 minute, is that everything in the YSUN 1.0 FAN profile is standards-based. It's either an IEEE standard, or it's an IETF standard, or it's a standard from one of the other major standards organizations. There is nothing that is proprietary in the YSUN FAN 1.0 spec. We can, with a standards-based solution, it enables media diversity. So we can provide a better total cost of ownership, because when you have a standards-based solution, you build an ecosystem that allows you to do significantly more as it relates to, we'll say, as it relates to, I'm sorry, I got to go back. As it relates to getting different vendors with different solutions. We wanted to get, as I said earlier, just enable that distributed intelligence. One of the things that we felt is if you could get smarter devices at the edge, you could make decisions at the edge. And so when it came to things like outage management, you could do things that you could not do in today's networks. You could reroute circuits. From the perspective of distributed energy resources, you could start to island total systems where you would have distributed energy resources in a small group of, in a neighborhood or a small group of houses who could run off the distributed energy resources and not have to rely on the grid. The other thing that was very important in the United States at the time was the regulatory requirements were starting to build, where we had to build things that were IP based, and it had to be bidirectional. It couldn't be a network where all you were doing was taking in information. We had to be able to put information out as well. And so when we started looking at that, it required a significantly more robust network than what we had currently. And we looked at how we would do that. And when we looked at Wi-Sun, it was certainly a network that could do all of the things that we required relative to that. So the other thing that's really important, I'm going to talk about it near the end a little bit, is the one thing that Wi-Sun has that almost all of the other solutions don't do a good job of is security. The United States NERC CIP requirements, which is the National Energy Resource Commission, and their confidentiality and information relative to their network, they have very strong requirements in how they do that. And if a utility isn't following those NERC CIP regulations in the United States, the utilities get fined. So from the perspective of utilities who are trying to protect their information, and if you look at Europe, they have a lot of privacy laws as well. The grid security that we have put into Wi-Sun secures that utility IP network for grid operations. It provides physical security and remote workforce management security. I believe of all the solutions out there, it probably has the most robust security that we could provide. And I think that it's going to even get better as we move further into the FAN 1.1, 1.2, and onto FAN 2.0. We continue to enhance that. And I would like to point out that it is standards-based as well. Cisco is very, very big on standards-based solutions. This is kind of an overview of the open standards IP-based reference model and how it applies to Wi-Sun. And if you look at that little red dotted box, that is where Wi-Sun lives. All of those are totally standards-based RFCs, standards, specifications. If you look at the base, it's IEEE 802.15.4. It has we also have IEEE 1901.2 if you're looking at PLC, which is using the same 802.15.4 frame format. We use standard IETF RPL, and we use standard RFC 6282, which is 6-low-pan, which is also an IETF standard. The nice thing about open standards is, again, it ensures interoperability, reduces technology risk for the utilities. They now know they have a solution that's going to last them for 15 to 20 years, because the thing that happens with standards is that pretty much future-proofs them against proprietary solutions, which change over every 4 to 5 years. It's assumed that the internet currently has about a 25-year lifetime, and it's continuously evolving. And the beauty of using open systems or open standards is that it allows us to evolve with those standards. We have media diversity in YSUN, which we have one FiMac technology. And one of the things we want to ensure is that we future-proof all environments. So we spent a lot of time at Cisco looking at where the best solutions for this were. And it was obvious to us that YSUN was the place to go. And so we decided to put our trust and our faith and the full efforts of what we were doing relative to utility networks and RF mesh into the YSUN Alliance. If you look at Cisco as it relates to YSUN, we are a leader, and I can say that I could say that without reservation. I was the chair of the 802.15.4 2020 task group. I was also the chair of the IEEE 2857 standard, which is an adoption of YSUN FAN 1.0. Along with Professor Hiroshi Harada, who was my co-chair of that particular effort. I serve on the YSUN board of directors, and one of the people on my staff, Paul Duffy, is the YSUN technical task group chair. So we have put a lot of effort into YSUN because we believe YSUN is a solution that utilities are going to want. With the over 200 members representing 26 countries, which was really closer to 300 now, we have multi-vendor, we have customer choice, and a robust certification program to ensure interoperability. And of all of the things on this slide, one of the things I'm most proud of at YSUN is our certification program. I have seen all of the other low power wide area networks, and I look at them from the perspective of how they've done with their certification programs, and none of them has done nearly as well as YSUN has. We've put a lot of effort into that certification program, and it has paid off. Open standards, as I've said, build larger and stronger markets. If you want to build an ecosystem of products, if you want to have something where you have multiple people's engaged, and if you want to build networks where multiple people can take part, it needs to be built on open standards. It allows you to build larger networks. It allows you to put more devices on as people learn more and as they design these devices. We've seen things like factory automation move from proprietary field buses to standards-based IP networks. One of the other groups I work with is a group called Avenue, and they're working with internet-based IP networks for factories, which years ago was not considered anything that you would want to do. But if you look at what we were doing with utility networks, it was the same way. It took us probably 6 to 7 years before we got utilities to understand why it was better for them to have these open standard-based networks. And they now understand, and they are now starting to develop those networks, and they're starting to understand the solutions they can provide on their networks as a result. These things are pretty obvious. When you have open standards, it increases your vendor's choice. If you're using a good standards-based security protocol, it enhances your security. And the other thing that it does is it enables all sorts of applications. If you go back to that first slide where I showed you probably 40 different applications that we were looking at for providing to utilities, you couldn't have done that without an open standard-based network. So it enables those applications. What happened in the industrial market for those things which went to Ethernet, we believe YSUN can do the same for wireless critical infrastructure networks. And we are starting to see that. We are starting to see YSUN deployments that are not only smart metering, but they're using they're doing distributed energy resources, they're doing distribution automation, they're doing edge computing, they're doing smart cities, they're doing smart lighting. All of those things are a result of having this open standards-based network. From a Cisco perspective, every one of our products that we offer for mesh wireless is YSUN certified. In fact, the first YSUN certified border router was our CGR 1240, and the IR 509 was one of the first testbed units that was used inside of a certification testbed. So we have certified every product that has come out of our engineering department as it relates to mesh wireless with YSUN as soon as it came off the line. I think we now have 15 or 16 certified products with YSUN. And in fact, we have a prototype that people can buy, that they can use, that is available in our DevNet network. So we have a reference design that's available on our DevNet network, and people can go out there and get the reference design and build their own device. If you look at what we're doing with our multi-service field area networks, you'll see that we've got our data center and enterprise apps and things that we do on the premise relative to certification. We have our own certification authority, although YSUN does offer to two certification authorities with Global Sign and I'm trying to remember the other one. We have two now that we've offered from other cert authorities. We have intrusion prevention. We have our own field directory services, access control. We have a number of distribution management system products for companies that are looking for those. Our flagship product for YSUN right now is the IR 8140, which does Wi-Fi, LTE, Ethernet, fiber. Any of those things can be used for backhaul. And of course, on the other side, it does YSUN. So the backhaul is Wi-Fi, LTE, Ethernet, or fiber. But on the field area network side, we have a number of devices that people can use for their networks. And in that particular networks, we're doing those applications you see at the bottom. All of these are currently being done with Cisco equipment: streetlights, street meter or smart metering, charging stations, load control, transformer monitoring, circuit line indicators. All of those are currently applications that utilities are using with Cisco equipment. This is a really quick. I'm going to go through this relatively quickly because this is a real quick overview of the security inside of YSUN, which we're very proud of. It's based on IEEE 802.1x authentication methods. So it uses keys, it uses group temporal keys to get started. So if you look at the left side, you can see that the endpoints can't talk to the endpoint or can't really get to anybody else until they've shared this group temporal key, which comes from the cert owners. And then what happens is it goes along and it starts to share keys, and those keys then start to build the network out. And you have now pairwise master keys. We're looking at actually getting into pure pairwise keys as we move into other versions of FAN. So the initial security credentials are shared, and then they then exchange their own private keys. And of course, when that happens, we have encryption running across the entire network. To ensure that we don't have a lot of costs relative to the extended authorization protocol and TLS, we typically set the key to 4 months, but that is totally customizable by whoever wants to put this into their network. One of the things that we do ensure, though, is that all of the key management is is pairwise. So there's a shared secret between the CGRs and the endpoints. We establish the channels between the CGRs and the endpoints, and we limit the use of those keys and try to extend the lifetime of those. From a perspective of frame security, we actually use an AES 128 key. So with cipher block chaining and counter modes, and this is used for every frame. So all the frames are secure. We have integrity, authenticity, and confidentiality. The shared secret is common to all devices granted access to the network. So all of the networks understand the keys that are within each other, and they do that. You can see what the actual header of that looks like in the authentication. And messages not signed by the GTK are just dropped. So if the group temporal key is not shared, then anything coming from any other device is simply dropped. And of course, one of the things that we do have is a mesh refresh. So every so often you want to change that, and you want to change the keys that are being shared. And when that happens, we have a method for doing that. And again, it's all standards based. It's all using IEEE 802.1 I, and these things are all standards based, and they're all ensuring that security is maintained across this network. And I think that's all I had.